Okay, so today we're going to start off talking about division. And if you don't like math, you probably really hate division. No one likes division. I don't like division. So there's a couple of things I want to talk about when it comes to division. Basically in terms of how you put it in the calculator and as well as how you actually write it. And then we're going to do a little bit of long division. I'm not expecting you to know long division like amazingly, because if you use your calculator, I'm okay with that. But the thing with division in your calculator, you really need to know how to input the numbers in your calculator properly. And one of the biggest problems I find is that people are not putting the numbers in the calculator properly and therefore getting the wrong answer. So let's look at a couple of easy division ones first. Here. Let's look at this one here. Number 13. Practice 13. Here. Alright, so I was going to take that and complete that question there. You see there's two pieces I got to worry about. First of all, I got to worry about the piece in front right here, the 8, and I got to worry about the number in here. Okay? If I were going to read that out so that it makes sense in words, it would be 932 divided by 8. Right? So taking that, if we were putting that in our calculator, you put it in the calculator like this, in this order here. Batteries again. Oh yeah, I have to replace it with batteries. So I will put it in the calculator would be 932, and I go divided by 8. Let me see, I get 116.5. Most common mistake I see is people go the opposite way around. They go 8 divided by 932. Okay, which is not correct. Don't do that. So if I were to write it this way, it's very now we see it's 932 divided by 8. Or I can do this, 932 divided by 8. Again, it would be input in the calculator the same way. The 932 goes in and divided by 8. Or it can be written as, yes, 932 over, just to confuse you even more, this can be written 3 different ways. They all mean the same thing. And it's always divided in the calculator. The one in here, this one, or this one will be input in first, divided by the 8. Alright? So we will do that using long division, which we don't like doing, but we got to do it anyway. Move over here and I'll say 8. This is where we're going to start talking about gazintas. Anybody here tell of a gazinta? New math stuff, it's called gazinta. So it goes like this: 8 gazinta 9 one time, right? It's short for goes into 8 gazinta 9. I saw those in a cartoon a long time ago. I even forgot it. In any case, it was kind of funny. So 8 gazinta 9 once. So what we do with long division, if 8 is being divided into the 9 right here, the number that divides into it evenly goes up on top. Okay, just quickly review how this works. This number then gets multiplied by that number there, and right down bottom here, and subtract. And then these two numbers here, they just pop straight down. So subtracting 8 from 9 gives us 1, and then we got 32. Alright, so now moving on to the next part. Now we look at it this way here. We have the 8 cannot divide into the 1, so we have to look at the 13 now. So then we ask ourselves, how many times can 8 divide into 13? So we know once would be 8, twice would be 16, it's too high. So I can only win there once again, right? So I put a 1 up top. Notice how I just keep everything lined up. The best thing with this long division is keep things lined up. And again, 1 times 8 gives me 8. And I subtract again. And 13 minus 8 gives me 5. Right? And then the next thing I do is, again, it's the same process over and over and over again until you get down to the end. Now just like 8 I'm not going to the 5, but it goes into 52. And this is where times tables comes into play. If we get better at those, this makes it a little bit easier. So if we have 3 8s is 24, 4 8s 32, so we can keep on going and try to find out what number we'll divide into 52. And if you think about it, 6 8s will be 48. So we put a 6 up here. Oh, it's not green. Get my colors lined up. 6 up here. And the 6 multiplied by the 8 gives me a 48. And when I subtract those numbers, I get 4 as a remainder. So the answer would be, looks like this. Or you can rewrite it as this right here. The answer, you can read it like this. 1 1 6 4 over 8. And we'll leave it at that for now. You notice the difference in the calculator because it says 0.5. Well, we didn't do fractions yet, so I'm going to leave it at 4 over 8. Because if I took my 4 divided by 8, those people who already know the answer to this, took my 4 divided by my 8, I get 0.5. Alright, that's where the 0.5 comes from. Yep. This right here. Yep. Yep. They're both correct. I can rewrite it this way. I can show you. We would not leave it as a 4 over 8. Normally we would reduce, but since we haven't talked about reducing yet, I'm not going to mention reducing. Reducing is a bad word. So we don't talk about reducing yet because fractions is the next chapter. But if you want to see how it can be written, just for your own, it can be written as 1/16, 1 over 2, or 1/16. Oops. 0.5. So all these here are the same answer, and they're all equally valid. So if you do your assignment, for example, and you put one of these answers in there, the most correct one would be either this one or this one because this is not reduced right here. But I would accept any one of those answers, and if the computer marks you wrong, I'll give you the marks for it. Okay, so don't worry about that stuff. Any questions on division? No? Wow. Just look at a word problem. We haven't done one of those yet. I know we love word problems, right? Who likes word problems? I do, said no, never. No, no one likes them. So, it says here that carbohydrates have 4 calories per gram. If the serving has 368 calories, I can talk today. How many carbohydrates? How many grams are there? What do you think we have to do here? I'll give you a hint. The part of the chapter is called division, so that's a big hint. All right. So when I'm doing a word problem, first thing I always do as I'm getting started is I always write down what I'm given. So I'm giving right here, I have 4, stop that. So I'm given 4 calories per gram, and I have 368 calories. So what I'm going to be looking at, I'm going to be looking at 368 divided by 4. Sweet, no problem. Or I can write it like this: 4 and 368. And do it the long way. So when doing it the long way, the 4 cannot divide into 3, right? I've been going 36. How many times? Because the 3 goes 0 times, right there. But how many times can 4 divide into 36? Hmm? Good one. 9 times. And then if coincidentally enough, that actually happens to be 36. And it's a 0. Then the 8 just drops straight down. And we have an 8. And we know that 4 can divide into 8 2 times. And let's subtract the 8. And it's 0 remainder. So the answer is 92 grams. Notice again what I want to point out as well, how when I did these, I lined these things up because the 4 would not divide into the 3, but it went into 36. So I'll put my 9 over the 36. Did you notice that, how it lines up? And then the next one, the 2 goes over the 8, it all lines up. So keep it all lined up, and that's what we want to do. Okay. Any questions on division? I'm moving through these basic operations pretty quickly. So, and again, don't forget your calculator still right here. So if we went back to the last example, we could just go, what was it? You still just go 368 divided by 4 and gives 92. Okay, so you can see that's how you put in your calculator. Okay, that's how it looks like. Now, this is where the real math starts to come into play. The next part right here, where it's solving for an unknown number. Before I start this part right here now, I want to just pause for a second and have a little talk about something that I don't think people in high school, in my awareness, spend much time talking about it. And this is where I think a lot of confusion comes in when it comes to some basic operations in a word called algebra. Remember when letters come into play? Who likes letters now in math? No one likes letters in math. Don't put your hand up. Don't say like letters in math. No one likes letters in math. In any case, that's where they come in. So what I want to talk about is just this piece right here for one quick second. Like this one here, I want to show you something that's pretty neat. When it comes to this next piece I'm going to do, all that matters is that sign right there, the equal sign. That's all that matters. You're like, what? No one told me that before? That's all that matters. I'll show you why. This is going to be so simple that it's going to it's almost too simple to talk about. For example, all I care about right now is 10 is equal to 10. They're both the same number, right? They got to be equal, right? But what I want to show you, and again, when I do this, all I care about is make sure that those two numbers stay equal. That's all I care about. All right. So I can do this. I can play this game. I can say, no, I'll take 10. I'll divide this by 2. And as long as I take the other side, and I'll go 10 divided by 2, both sides still happen to be equal. Right? That's all that matters, right? They're still equal. I take the 5. If I add 3 on this side, I'll move down here, sorry, hang on. It's hard to do with blackboard, chalkboard or whiteboard. I love this stuff. So in any case, if I add 3 on that side, as long as I put 3 on the other side, guess what? It's still equal, and all I care about is that they're equal. I'm just picking the numbers out of my head, right? 3, it doesn't matter what number it is. Doesn't matter, right? Up here, if I have 8, it's equal to 8. I want to go, okay, well, say 8 multiplied by 2. As long as I multiply by 2 over here, both sides are still the same. You know everything you need to know about algebra now. That's it. I can worry about. You're like, really? Yours, this is not right. It's got to be harder than this, right? Always harder than this. This is not. All right, let's talk about it then. Let's go back here. And here's the example that they use. Oh no, there's a blank space right here. So if I want to find out what that blank space is, I'm gonna mess you up a bit more now in this, but just I'm gonna take that there. Oh. All right, that's not. We don't want to see that right now. Oops. Haha, now it's gone. All right, so, but what we know now, because I'm trying to cheating a little bit, tricking you guys. There's a blank spot. What goes in the blank spot? That's what we're trying to figure out. In the blue square, what goes in there? Well, actually, the blue square is, you're right, actually, the blue square is actually a hidden letter X behind the box. This is where algebra comes into play. So knowing what we know from the previous page, if I want to find out what the value of the X is, I need to get rid of this number here. That got to go. Right? So the easiest way to get rid of that is if I did something like this. If I went X plus 12. Remember, if I did this on that side, it's going to be equal as long as I do the same thing on the other side. So you see what's happening? I'm subtracting 12 from both sides. Are you all cool? That's pretty freaky. No, you don't like that? It's okay to say you don't like something. Because I'll stop and back it up. I'll show you a shortcut way of doing this in a minute. But what it is, so the reason why we do that is that we can't tell what this X value is, right? Of course I can. I can just go over here and say, all right, well this is basically, yeah, I'm just, you know, it's going to be, right? But if it was more complicated, we can just look at 63 and say 63 and 12 is 75 and we're good, right? But if we didn't know that easy what that was, you would take that 63. Oh, stop doing that. My x value goes back. My x goes back when I get all together again. My x back here. Now, if I look at this, remember, okay, whatever's on this side right here equals whatever over here, right? Go with that, okay? And back here we just said, okay, if I have 5 on this side, 5 on that side, if I add 3, I can add 3 and it's still equal, right? So coming back to this one, if I subtract 12 and subtract 12, it's still equal, right? Just didn't think that one's much. That's okay. But the reason why I chose 12, see, in math, there's always built-in hints of what to do that no one ever tells you about. And the hint is, and why you need to, how you need to know what to do is that you need to get rid of this number here. If you get rid of this number here, what's left? This number here, which will be equal to what's over there, right? So, to get rid of this 12, how do we do that? Right here. I subtract 12 from that side. But based on what we just said back here, I can't just subtract from one side. I got to do it on both sides to keep them the same equal, right? So subtract 12 over here. That makes a little more sense? Good. So 12 minus 12 goes to 0. So this goes, and this goes. I'm left with an x. And now 75 minus 12 gives me, that's where my 63 comes from. See? Let me try one more thing. This is the big concept, right? I want everybody to understand what's going on here because it's a big concept when it comes to anything algebra related. So it helps you visualize it a bit more. You can think of an algebra equation like the balancing scale, right? With this piece in the middle right here is the equals. And if I put something over here, this is going to go down. Unless I put the same thing over here, in which case it'll be the same again. So whatever you do on one side, you have to do the same thing on the other side, so that the scales don't tip. That's the same way it works in an algebraic equation, just like that. That help? I think there's one here that actually does this by itself, but I can't find it right now. Anyway, I'll try to find it later, but if you see the point I'm trying to say, both sides got to stay the same, right? So let's take the principle and do a couple more exercises with that. Let's look at the first one. 49 plus something gives us 107. How are we going to figure that out? Yep, but be careful how they say it though, because I'm going to say it's 49, 107 subtract 49, but that's exactly right, but just careful how I say it. So what he means, what he just said, we do this page right here. We go, if I want to do it I'll do it the long, drawn-out way first till everybody feels they're comfortable with it. Then I'll show you the shortcut. How about that? So now I need to know what's in here. So I've got to get rid of this number here, right? So I'll go 49 minus 49 plus my x value. And if I did it on this side, I got to go 107 minus 49. Make sense? Then these two basically disappear. Hmm. 52? Am I close? No. Let's cheat. My brain's tired. Here we go. But the piece I want you to get used to looking at is this piece right here. How we subtract from this side and subtract from this side. You okay with that? You are? Don't, you're not. Make sure you just say no. I'll do it another way. All right. So if we're okay with that, let's look at the next one. Next one's a little bit trickier. Doing good. So looking at the next one, we'll do it slowly. We have a blank here. Plus 12 plus 2 equals 68. Now there's a couple of ways to do this one. What I'm going to do first is what I consider to be the easiest way to do is to take these numbers here and add these two together first, and then make it simpler, and then worry about it after. So by adding those two together first, I get something like this. I get a blank space plus 14 equals 68. All right. Now we're getting kind of used to this now. We know what's coming up next. We need to get rid of that 14, right? So we got to subtract it from that side. So we have a blank space plus 14 minus 14 equals 68 minus 14. Then this side they just go away to 0. I'm just left with a blank space, which is my x number. And 68 minus 14 gives me 54. Be okay with that? Want to see the shortcut? The shortcut, this is a lot of work here for a simple answer, right? So the shortcut looks like this, and if you don't like it, just go la 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 la, and don't look and close your eyes, okay? Because if you're not ready for it and don't like it, that's fine. But it gets easier the more you do it. Let's take the same question we just did here a second ago. If I have a blank spot here and a plus and a 14. I'm writing this down slowly because I'm doing this on purpose. You'll see why in a second. Equals 68. Perfect. How do we do that? So the shortcut is, you'll notice first of all, looking at this here, you'll see there's a plus sign right here. So the shortcut doing these basic operations is, if you wanted to, I could just take this number here, move it over here, change the sign from a plus to a minus, and I'm done. So you see now, it's just going to be, oops. Make sense? So all I did, just to recap that, just take the number, drag it over there, change the sign from plus to minus. That's easy. Ta-da! Nailed it. And it doesn't matter if it's multiply or divide, whatever, just do the same on both sides. So what I'm trying to say is that those dividing on this side, so let's do a division, or multiplication division. I'll do a simple one, so you can all follow along. No, don't do that. If I have x divided by 2 equal to 7, well, the opposite operation of division, multiplication, so I can just say, if you want to see it the long way first, I can just go x over 2 multiplied by 2, do that on both sides, 7 multiplied by 2, these two 2's go away, and you see I'm left with my x value equal to 14. Or I can do this, x divided by here, I can simply go x equals 7 times 2. So all I'm doing in this case is skipping this step right here. If you don't like that, do it the long way till you get comfortable with it. But if you don't want to do it the long way, you want to do it the short way, that's the short way to do it too. Make sense?